Adding the game states to our catcher project requires us to have a way to monitor, to remember what our current state is. And to do that, what we're going to do is we're going to introduce a new variable. And with this variable, we're going to use a string because that allows us to represent it as a word. Now, in some programming languages, for doing a game state, what we actually represented as a variable type, we use what's referred to as a constant. A constant is going to be a value that once the program is compiled, that value can't change. And then we have game state, and we set our game state equal to one of our constant values, a constant value of play, start, stop, win, lose, whatever different states that we want our game to have. But we're going to use a slightly simpler version. So we're just going to have a variable, and we will call it game state. So when we have the variable of game state, we can set it equal to any number of different states as we see fit. So we can add in different states. So on the next line, I'm going to just put a comment and list some of the states that we will be working with. Now, it will be, if you notice, one of the things that I'm doing here is I'm representing my different game states with all capital letters. And the reason for that is because we're using what I would refer to as kind of a pseudo constant. So the variable type of a constant versus a variable as a quantity, it's a thing we're remembering, but it can change its value. Like score changes its value from 0, 1, 2, 3, 4. Our string S can change to different combinations of letters. Our game state is going to be one of these fixed values: start, play, win, lose. And if we realize our game needs additional states, then we can add those down the road as well. But a tradition in programming is constants as a kind of a variable type get represented with all capital letters. So it makes it easy when you look through code. You see the all capital letters like, oh, okay, that's a constant. So it kind of stands out from other things. The same way that using camel casing allows us to recognize things. A class always begins with a capital letter, so we can recognize that. So by utilizing these conventions when we're coding, it helps us to be able to make our programming a little bit more human readable. So these are going to be my starting states for my game. So currently, in my draw function, I have a whole bunch of code there that we will be dumping into one of our game states. And it will probably make sense that the bulk of that code goes into the play state, because that's all our game was doing previously, is you hit run and it played. There wasn't a start, there wasn't a win, there wasn't a lose, it just played. So we're going to work through adding in start, have start transition into play, and then we will figure out how to make it possible to win and lose the game and work with that. So now that we have a game state variable, we probably will need to assign it a value. Now the value that we will want to assign to it in the beginning will be our first state, which would be start. So I'll just simply say game state is equal to, because it's a string, I put it in quotation marks, and then I will finish with my semicolon. So now if I run my program and look at it, nothing's changed since last week. It's still going to run the same. I have this game state value, but it's not doing anything yet. And now this is where we want to do something. So that's where I'm going to move into my draw. And as we add in the logic and the programming for the game state, then we're going to take the existing code that is currently in our draw function and consolidate that into some different places that hopefully will actually make all of what we're doing more organized and actually easier to read. It will be a few more lines of programming to do that, but through the process of doing that, it becomes easier to read, which is the ultimate goal for what we're trying to do here, is to make well-organized, easy-to-follow programming that, oh, by the way, actually works. So if we start out with an if statement and say, if game state is equal to start, then we want something to happen. Then I will just continue that with if else game state is equal to play. We will want something else to happen. Else if game state, and at this point it just gets a little bit repetitive while we add in our different states. And after we get lose, so we've defined an if-else if statement based on the current states that we have conceived of for the project so far. It makes sense to add in a default at the very end that's not tied to any of the game states. So if by some occasion our program forgets what the game state is, at that point, then we will want to send out a message or do something. So I could write words on screen. I could just print out a line to the console and say, hey, you know, something is broken here. I'm just going to say text, oops, something is not right. Again, remembering that with a text statement, we just have to specify what is the string we want to have appear on screen, and then where do we want it to appear in X and a Y location. So now that I have set my game state at start, we need something to happen because my draw function says, hey, if gameplay is start. I'm going to take all of the code that was previously inside my draw function, and I'm going to wrap that into its own function right now, and I'll call that play game. Because I want to keep my draw function a little bit cleaner looking. It will make it easier to understand. So my gameplay is start. Well, nothing's going to happen yet because my gameplay is start. So if I run this, let's see if any magic happens. It did exactly what it was supposed to do. No error messages and a gray screen. So it's behaving exactly as I wanted. Now, for some of you, that might be, well, you want more on screen. A gray screen's just not really enough to get you excited about the process. But there's no error messages, so sometimes that's a good thing. So if my gameplay is start, one thing that we could do is we could listen for, say, the user to click their mouse on screen. We could even put a message on screen and say, hey, you know, why don't you click the mouse? Click the mouse to begin game or something to that effect. So I'm going to do that. Anytime I'm using text, I should always specify a color. So I'm going to just specify black for now. I'll go back and change that to something more interesting once I figure out what I want it to be. So I'll say fill color, text, click to start. And I can put this over 100, down 200. We'll worry about the placement of it and making it look nice and changing the font and changing the size of it and doing all those nicety things. The aesthetics Well, we'll worry about that in a little bit, but first, right now, we just want to get it on screen. So now if I test my program, I will see that words come up and it says click to start. Now, if you look close, you'll notice that the words they start out looking okay, but they get really fuzzy really fast. And they start to get kind of chunky. And what's happening is 60 times a second, it's redrawing the words click to start on screen over the top of itself. So the letters which have a natural kind of anti-aliasing or smoothing on their edges, that starts building up. So if you take 10% transparent edge and after 10 frames, you've now taken that 10% transparent area and it's now 100% opaque because it kept stacking 10 plus 10 plus 10 plus 10, and now, so at a fraction of a second, it starts to get very chunky and fuzzy. So one thing that we could do is we could just write the background color, and I'm going to fill my background with white. So if I flood the background with white, set my fill to black, draw the text, now this time when it comes up it will be a little bit cleaner. Potentially I could be using my clear background function that I already have and doing something with that if I made sure that was kind of written to do what I wanted. And we'll worry about that kind of that optimization of not doing the same thing in different places. We'll try and see how it can be more efficient. But as always, start simple, get it working, and then go, okay, now can I do this better? Can I make this more optimized? Can I make this cleaner? But the first thing should always be get it working. Just get it running. And once that occurs, then we can add more to it. I'm going to move my X over quite a bit more because I don't like it way off to the left. I want it a little bit more centered, just so that's a little too far. But again, you can figure out where you want to put your words. You can apply text formatting so it centers the text, and then you can draw it in the middle of the screen. There's all kinds of options that you can explore as you're going to build your own user interface and make it pretty. Maybe have a more exciting message than click to start. That's pretty boring. So I will expect on your projects that you will try to be more inventive. And this is also on the starting screen where you can provide some instructions. You can tell the person, are they trying to avoid something? Are they trying to catch things? Are they trying to catch things before they hit the bottom of the screen? Are they trying to catch things that are flying across the screen? However you've chosen to interpret the catcher, this is a great opportunity to provide that instructional component to the user so they know what they're supposed to do. So now at this point, we need to figure out how to listen for having the mouse clicked and working with that. So what we can do to pull that off is we can do exactly that. I can say if mouse pressed. So mouse pressed, there's a mouse pressed function. So we could set up a mouse pressed function and say, hey, if the game state is start, then change the states and do all that. So we could set that up in its own function, or we can just put an if statement here and say in the draw loop, it can now listen for the event of mouse pressed. And if I say if mouse pressed, that's equivalent to saying if mouse pressed is true. Mouse pressed is something the mouse is pressed or not. So if I'm asking the computer, has the mouse been pressed, it will say true or false. So if mouse pressed is true, meaning someone clicked the mouse, then what we can do is say game state is equal to play. So now my start state fills the background with white, changes my fill color to black, put some text on screen, and then listens to see if the mouse is pressed, and if so, it changes my game state. If I run it, it crashes. So I screwed up and put in 2 equal signs when it should have been 1. Oh, no, that one should be 2. And the next line down is 1. A single equal sign when I'm assigning a value, a double equal sign when I'm checking a value. So now when I run it, no more error messages. It says click to start. I click, and nothing happens. But technically, my game state did change to play. But I didn't put anything in my game state to play, so I don't get to see anything. I could put in a message here and say text game state. Put it on screen here. If I click, we can now see how I put it on screen. Click to start stays on screen because we never issued a command. Once my game state changed, it no longer is clearing the background, which is why also you can see the difference in text where play looks all chunky because it's rewriting 60 times a second. It's putting the word play on top of itself, where before with click to start, we would flood the background with white and then redraw the words on top. Now that I know the game state works, I don't really need that there. I'll just leave that line there for the time being. I can always delete it out because it's a comment. Comments can always go away. And what I'm going to do is put in I'm going to call my play game function. Now, if I call play game function in here, it's now going to call everything that's in play game, and now I can hopefully play my game. So if we run this, it'll come say click to start. I click to start, and now I have my game. That works. Now I'm going to run that again. I'm going to hold for a second here. 2, 3, 4, 5, 6, 7, 8. Okay, more than a second. 10 plus seconds. Because one thing that's happening with that is if I were to play my game, one thing that we're doing slightly out of sequence is my setup is telling my timer to start running. But the timer really shouldn't start until I'm ready to tell my game to start. So we probably don't want that there anymore. So I'll comment that one out. Now, one thing to keep in mind, anytime you start doing wholesale like grouping, reorganizing, moving around of code, it's not a bad idea to do a lot of commenting out of code and then copying it and then pasting it in elsewhere, versus if you just start cutting code and moving it into new places, you're probably going to bork your program pretty quick. So if you leave everything where it is, so you can see this is where it used to be, and then you get it working, then you go through and delete all the extra commented code. It's the same way if you're trying to solve a problem. Every attempt you try, if it doesn't work, comment it out, but leave it, because there may be a logic or a piece of wisdom in there that you don't realize you need until you need it later. And then you're like, how did I write that again? And it was like a really cool line of code, and then you don't remember. So before we change our game state, it makes sense to just tell our timer to start. So when I press the mouse, start the timer, change my state to play, and now we can play the game. So now I have a running game. Now this particular game, it kind of is, it's a play until you win, but we're never really checking to see if we've won. All we do is catch all the objects and throw them off screen. So the next kind of order of operation is to figure out how to put into our game state, or our play game function, how to figure out has the player won or has the player lost? So we're going to move into that. Next is figuring out what is that condition that would determine that someone has been successful or unsuccessful. So all of this is going to go into a start game function. So I am going to copy it, comment it out for now, following my own advice of don't start moving things around, deleting, and I will just call a start game function. So I have play game, now I'll have a start game, and then it's just a matter of figuring out how to write it, which is void start game. And then paste that code in there. So the functionality is the same, but now my draw state is becoming increasingly more organized. We now have one function that is specifying what is going on, making it a little bit easier to follow. So winning is going to be catching 5. And I'm just going to get this out of here just so we have a little bit more on screen. So winning is catching 5. And then if I've won, what I want to do initially, I'm just going to say, put some text on screen. You are amazing. And so that the text doesn't look chunky, put in a background color. And now I'll just bring it back to white, choose a fill color of black, and then put text on screen. So if we've won, I'll just put some words on screen. Now that our win state has something in it, and the lose state could be very similar to the win state, that you could just copy paste that into the lose state and say, oh, you're not, very skilled, are you? Or some other derogatory, or better luck next time. We'll try and be positive. We won't just be condescending or mean-spirited. But you can write whatever you want there. So you could put that into a lose state, and we'll work with that. Now, to do that, we need to look and play game and go, okay, where does it make sense to update the game? Where do we want to figure out that we've indeed won the game? So after discussion, we've determined we could pretty much anywhere inside the play game put it. We could put it after the text, before this text, because right here it's being caught. As long as we put it somewhere in this play game function, if score. Now I'm going to advocate that we want to say greater than or equal to the number that we're looking for versus equal to. Because what we don't want to have happen is, what if we intersect two objects at the same time and somehow it registers both before it's gotten down? We don't want it to over-iterate our score and then realize we've now passed that threshold. So if my score is greater than or equal to whatever amount I'm checking for, and I'll just start out with 5, that should be enough to begin with to prove that we can win the game. We can just simply say game state is equal to, and remembering it's a single equals now, not a double equals like when I screwed up earlier this afternoon. Game state is equal to win. So remembering that I have my 4 game states that I talked about at the beginning: start, play, win, and lose. So if score is greater than or equal to 5, game state is now equal to win. And when my game state is equal to win, it will now go to this part of my draw function, and white background, black text, you are amazing, at 200, 200. So now if I can catch 5, so click to start, 1, 2, 3, 4, 5. Well, I tweaked it a little bit there and screwed up, so let's choose fill of black so that now this time it will work. And now if I try and run my project again, click to start, 1, 2, 3, 4, 5. You're amazing. Now what I don't have is any way to restart my game. So that would be something to think about in addition to figuring out lose. So a basic concept that we could play with, knowing that in the beginning under start game we said, hey, if the mouse pressed is true, we change the playback to start. So first, I'll just throw that in my, let's see, I don't have a win game function yet because I put the code directly in here. And the new code that I'll be adding into it is this, which is if mouse pressed is true, restart the timer, set my game state equal to play. So knowing I really like the prettiness of start game and play game in their own little functions, I am going to make a win game function. So I can put that code into it as well. Because it really does, I believe, make your whole project just a little bit easier to read. So when we see what these game states are, and it also keeps your game state conditional statement really clean because you just see what is the state and then what function is being called. So you don't have hundreds of lines of code, which you eventually will be moving into, where your different states are potentially going to be fairly complex. Right now they're kind of simple, but they're going to get more complex. Now if I run this again, so we can see right now our game state is start. I click to start. Now I get to play the game. 1, 2, 3, 4, 5. And now if I click to play again, running into a little problem. Right now, my game is not resetting itself because when after I win, if I press the mouse, it sets my game state back to play. So before we do that, we need to reset a few things. Score is equal to 0. Got to bring the score back down so then I can play the game a second time and a third time and a fourth time. We're not doing levels yet. We're just doing, you play and then you'll win, and then you'll be able to win or lose and reset, but we're not going to worry about levels too much just yet. Click to start. 1, 2, 3, 4, 5. I won. And now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we can see it's going to keep going. And if I do this, it will go 20 times. And then it will be stuck. Because another thing that is going to happen is I'm going to run out of drops. Because currently my game is set up so that I have 100 drops. And every half second it drops a new drop. If I catch 5 each time I play the game, after I play it 20 times, I've used up all 100 drops because active drops never got reset. My drops are, once they're caught, are not ever being reset. Because if we look in our drops, the drops don't have a reset value, so even if I called their reset method, nothing would happen. So inside my game here, we're going to have a little problem that if I play long enough, I will run out of drops. Because the drops have been caught, they get stuck off screen, and they never get to fall again. So that's a problem. that we need to address. When I am only catching 5 at a time, and if I have 100 drops in my pool, I probably won't notice. But if I set my number of drops to 10, and this is part of the fun, well, I view this as fun, the fun part of programming where you do it and then you realize, oh wait, it works until, and now you realize it's not quite perfect yet and you have to figure out how to make it perfect. Because now I can catch 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now there's no more drops to fall because the drops, once they're caught, get parked off screen. So we're going to have to figure out how to reset the drops, how to make it possible for the drops to then become active drops again. And we probably will need to even make our active drops variable reset itself back to 0 each time we reset the game as well. So what this reveals is when we play the game, if we want to reset the game, which is essentially what's happening here, we kind of need to reset everything. You need to reset all of the objects. You need to reset your score and any other kind of game control variables and get them all reset to starting or default values. And in doing so, then you will be able to have a continuous and permanently running game. The next thing we need to figure out is how to get it so that when I click the button to try and play again, active drops resets itself so then it doesn't leave everything on screen that was already on screen, but also so that I can make the drops themselves reset. I'm going to change my number of drops temporarily to 15, and again, so I'm catching 5. If I wait long enough, in this case 30 seconds, we'll have 15 drops falling. So we'll see all the drops falling in just a moment. And my random doesn't look very random as it's very right side of my game. Okay, so now that I have most of my drops falling, I'll catch my 5. Great. Now the moment I click to play again, what you'll notice is all those remaining drops will be exactly where I left them off. Because the moment I change my game state, we no longer tell them to update themselves or display, because we don't see them, but we never told them to go anywhere than where they were previously. So the moment now I click to play again, you'll see that they're all right exactly where they were on screen and they just pick up where they left off. So it's kind of like when I shifted to the win state, I just hit pause on my falling objects. And if you have 100 objects falling and you catch 5 to kind of win your first level, but all 100 were now all falling, it's going to be ugly when you start that game over, because now you'll have 95 things all suddenly in motion right where they left off. So I can catch the other 5, and then we'll notice there was a drop kind of on the screen right about where I'm putting my mouse, and we should see, well, I ended up, I think, almost catching it. And then once I catch these, there's no more to catch because I had 15. I've caught all 15. They don't reset. So the first thing I can do to get rid of the fact that I have the drops all active when the game restarts, the same way I reset the score, I can tell active drops to go back to 0. So now when my game runs, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so now I've caught 5, but now 1, 2, 3. But some of the drops are starting where they left off, because when they become active again, they're now remembering that, oh, I was in the middle of the screen. So I'm going to resume my falling motion in the middle of the screen. No, you're supposed to start up high and drop back down. So the final thing that we can do is we can just go through and tell all the drops, whether they were falling in the first place or not, we'll just tell all the drops to reset themselves. That means that we'll dump them all off screen, up high, give them their speed back so they're no longer caught. And so resetting them is kind of the opposite of catching. We're catching killed their speed. Now we're going to give them speed back, we might as well give them a new random X location, new random Y location, and all of that. So this means we will go into the drop class in a moment, but first what I will do is I will write a for loop. And we can just start it out as less than my number of drops, because we're going to just cycle through all of my drops and then have I go up. So a standard for loop like this is the same kind of for loop like I used here, so I could have even copy pasted that in. And then just do drops, and now I'm accessing item I in my array. And we'll call reset. Now the drops have the reset method already in their class. It's stubbed out, but it doesn't do anything yet. But we're just going to say, hey, drop reset. And we'll let the drop worry about how it resets itself. From a distribution of labor, it makes more sense not for me right here to say drop I dot x equals this, y equals this, speed y equals this. It makes more sense to just say drop reset and let the drop take care of its business. So when we write our programs, it's best when we have an object, we have a class, that if it has, we want to give it the ability to worry about its own condition. And we just say, you know how to reset yourself. And the good part about this, if we build future classes following a similar structure, is that then my core programming here doesn't even have to change. Because if the next object I build has a reset method on it, but it resets differently, instead of resetting at the top, it resets to the sides, or it resets to the bottom, or it resets a color, it can have all of its own reset functionality however it wants it to be. But we need to now provide that, because the drop class at the moment, while it has a reset method in it, that reset method isn't doing anything yet. So I need to make that reset method do something. And what I will be doing is I will be setting my X to a new random position. I will set my Y up top. And then I will set my speed to a new amount. So the drop is effectively reinventing itself. And I could retype all of those, but I think it'll be just as easy to paste it in. So we have reset. Now this is slightly violating that principle of dry programming of don't repeat yourself. I just repeated 3 lines of code that were elsewhere in my class. So there would be a way to optimize this and make this a little bit cleaner. I probably would want to take these 3 lines of code and put them in their own function and then just call that function from these 2 places. That would be a better programming method, but it's only 3 lines. I can live with that, a little bit of repetition. But anytime that you have lines of code that repeat exactly, especially blocks of code like that, that should be the mental flag of like, there's going to be a more optimized way to do this. But as always, get it working first, and then worry about making your code optimized. So click to start. I click to start, and I catch 1, 2, 3, 4, 5. Now square 0, 1, 2, 3, 4, 5. And we can see each time. So once I catch 15, 2, 3, 4, 5. Now I can play this all day long or until I get seriously bored. So right now it's set up. I update my drop. My drop by reversing the order. I first check and see if I went off screen last time, and if so, then I put it back up high. Then I add in my speed y. So that was moving speed y. So it's after the height check instead of before. Then I now look at my code. So I update the drop. If the drop now moved off screen, I'm now checking that same value here. Make my score go down so it becomes negative, and then I'm in good shape. Except for the fact that at no point in my game am I checking my score to find out, do I have such a negative number that I'm a loser and need to lose? So we need to put that into the game to kind of round out this whole process. Now you get to determine your criteria for winning and losing. I'm just going to say if the score becomes negative, you've lost. I'm going to make it that you can't let one go by in the beginning. So if I say if score is going to be less than or equal, if score is less than 0, that's all I need to do. If score is less than 0, game state is equal to lose. So if my score becomes a negative amount, I have now lost the battle. We run, click, I'll catch 2, now we watch score go down, and now it's -1, and the game froze because well, it didn't really freeze, it just stopped updating, because if I go back up to my draw function, I never put anything in my lose. Lose is probably going to be almost identical to win, except that instead of an affirming message, we will have a non-affirming, or maybe a supportive message. I bet you can do better next time, or something to that effect. So, all right, lose game here. Lose game. And then it's just a matter of figuring out what to put in it. For now, I'm going to put most of what was in my win game function, but we'll say you lost. And instead of a background color of white, I'm going to have a very harsh background color of red. So it will be bright screen red. To make it just a painful, harsh experience to reinforce the fact that you lost. And I'll change my text color to white so it's easier to read on that. But then if I press the mouse, then it resets everything and I can try again. Now when I run my game, I'll just lose right. Yep, now I've lost. Click to play again. So we can see that it's now starting to work. Now if I lose, prove I can do it. It's also possible to make your text branch onto multiple lines without having to use multiple text items. And there's a cool little escape code that we can type in our code. So when you have a text string, if you type /n, so the slash above the return key on the keyboard, if you do that slash in the lowercase letter n, that says you want a line return. And that inserts a line return between characters on your string, so then you can now put your text on multiple lines. Again, you're going to be encouraged to format your text, color, size, font, alignment. Use the help documents in processing, processing.org, to get some tutorials on how to do it using the language reference.